This is all about microscopes. The microscope you've got in the lab looks a bit like this, and it's got lenses in it. And the lenses make things look bigger or magnify things. Magnification is how much bigger things look. The lenses are made of curved glass, and there are two of them.
First of all, let's focus on a few terms that are important in order to understand microscopes. Magnification is one. That's really what most people think of when they think of a microscope. And we're going to talk more about that in a moment. But another term that is important is resolution. Basically, are you able to distinguish between two objects? This is important as otherwise two objects could actually look like one object because you can't distinguish between them. So for example, if a microscope had a resolution of 0.2 microns, then that means two objects need to be 0.2 microns or more apart in order to see that they are two different objects and not one. If you want to understand the physics of how resolution works and how it's calculated, we have a great further reading suggestion in the video details. So let's talk about some different types of microscopes that all take into account this need for magnification and resolution in order to see specimens. First, light microscopes. If you're in a classroom, this is likely what you have. And as its name would suggest, it uses light in order to see an image.
This light microscope reflects the light from the window up through a mirror. The one in the video had a bulb instead. If we now look at the microscope, the eyepiece lens is the one nearest to your eye, and it makes things 10 times bigger. The lens at the bottom nearest to the object is called the objective, and there are 3 of them. The one in the diagram makes things look 4 times bigger. So in all, 10 times 4, things look 40 times bigger. Now, if you change the objective lens to the one that says times 10, we've got times 10 times times 10, and it's 100 times bigger.
To be the one that I own, a bright field light microscope. Here is our light source. Light passes through this, the condenser lens, to focus the light on the specimen. The level of light can be adjusted by the diaphragm. Our specimen, likely to be on a microscope slide, will be placed on the stage here. Light will be reflected, refracted, or absorbed by the specimen. But we rely on these lenses here, the objective lens and the eyepiece lens, to get our total magnification. In fact, this is often referred to as a compound microscope because it has 2 sets of lenses. You can see that the objective lenses are attached to this revolving nose piece, which allows them to be rotated, so you can select a certain one that you want to use. With my particular microscope, I have 3 objective lenses. A scanning objective lens that magnifies 4 times, the low power objective lens that magnifies 10 times, and the high power objective lens which magnifies 40 times. But don't forget the eyepiece lens, because that also magnifies images, and my particular eyepiece lens magnifies 10 times. So let's say I used the scanning objective lens. I would multiply that objective lens magnification level by the eyepiece lens magnification level so that my total magnification is 40 times. Now you'll also notice there's a lot of knobs here. Let me introduce you to the knobs. This large knob here is known as the coarse focus, and then this smaller knob here is known as the fine focus. Both of these knobs raise or lower the stage, which helps with focusing. The coarse focus knob will move it more dramatically, whereas the fine focus knob will move it in smaller increments. These knobs, the stage knobs, don't move the stage up and down, but rather from side to side instead. It helps you explore what's on the slide itself, but it isn't adjusting the focus of it. Not all microscopes have those stage knobs. Sometimes you have to move the slide manually. This is the microscope arm and the base. Whenever you pick it up, you want to make sure you have one hand underneath, supporting the base, and the other hand holding the microscope arm. Since it plugs in, you want to make sure there isn't water around it. So let's take a look at what's in this water sample here. I'm going to do something called a wet mount to prepare my microscope slide. I'm going to drop a drop or 2 of my water sample onto the slide using a disposable pipette. It's like a very fancy eyedropper. kind of. I'm going to put a cover slip on top. There's some techniques to doing a wet mount to avoid air bubbles that you can check out online. Air bubbles actually can look kind of beautiful under the microscope, which can lead to great disappointment when you find out they're not some amazing microscopic organism, but rather just an air bubble. Something I may or may not know by experience. I'm going to put the slide on the stage. I'm going to use the stage clips here to secure the slide. Light is on, and I already have the scanning objective lens here ready to go, which is good because I want to find the specimen first. I can adjust the light level if I want, but just know that super bright doesn't always mean the best image. I can look through the eyepiece and use the coarse focus knob to move the stage up or down slightly to focus. Patience. Euclina. I can also fine-tune focus it with the fine focus knob. I can use the stage knobs to center my image. Now that I found it with the scanning objective lens, I'm now going to move up to the next magnification level. So remember, total magnification would be 100 times. Since I'd already focused it with the scanning objective lens, it's likely I only need to use the fine focus knob to adjust the focus. I could continue to move up to the high power objective lens, which would give me a total magnification of 400 times. Now, 3 additional tips about using microscopes that I just want to mention. Number 1, most microscope slides are glass, so they can break if dropped. And if using cover slips, keep in mind they are extremely easy to lose if not careful. Number 2, always be aware of where the slide is when you're moving the stage up and down with the focus knobs. It's possible to move the stage too close to the objective lens and actually crush the slide. And number 3, if it's hard to see your image even when focusing, you may need to clean the lens, but you need to do this by wiping it with lens paper, not regular tissue. When you're done with the microscope, make sure the slide is removed, turn off the light, lower the stage to its lowest
Don't
position,
forget the microscope
and
that
return
you've
the
got.
lowest objective lens over the stage.
The
Unplug
stage
it,
doesn't
wrap
move
up
up and
the power
down,
cord,
it's the
and
tube
if you
with
have
the
cover, cover
lenses
the
that
microscope
move
before
up and
putting it
down.
away.
Now please complete